Dear students, in this lecture we will study convergence and divergence of power series. We apply root test to power series. First of all, let us understand what is power series. Series of the form n is equal to 1 to infinity an x raised to n, where an's are real numbers and x is fixed real number, is called power series. An's are real numbers and x is also fixed real number. So this type of series is called power series. Note that we may take n is equal to 0, minus 1, minus 2, etc. So it doesn't matter whether we take n equal to 1, 0, 2 or minus 1, minus 2 and so on. So this is called a power series. Okay. Now let us see a theorem in which we will study convergence and divergence of power series. An is sequence of real numbers, so that this becomes power series an x raised to n. If limit of nth root of an is 0, then the series power series an x raised to n converges absolutely for all x. Secondly, if nth root of an converges to L and it is positive, then the series power series an x raised to n converges absolutely for all x such that mod x is less than 1 by L, and it diverges for mod x greater than 1 by L. So let us see proof of first result. So proof of first result, this is our hypothesis. What is given? It is given that limit of nth root of an is equal to 0. So this implies that limit of this sequence, limit superior of nth root of mod x raised to n, mod x is constant with respect to n, so we can take mod x outside, so that limit of this sequence equals to mod x into 0 and this equals to 0 for all x. So this limit superior of nth root of an into mod x raised to n is equal to 0 and it is less than 1. So by root test we can say that series n is equal to 1 to infinity an x raised to n converges absolutely for all x, because this limit is 0 for all x. So converges absolutely for all x. So this proof simply makes use of root test. We are simply using root test. If limit is less than 1, then series an x raised to n converges absolutely. So this was the proof of first part. Let us see proof of second part. So in second part, our assumption or hypothesis is that the given hypothesis is that limit of nth square root of mod n is L and it is positive. So this implies that limit of this sequence, again take mod x outside because it is constant with respect to n. So limit of this is equal to mod XL. Thus we have the fact that limit of nth root, limit or limit superior we can say, both are equal because limit exists in this case. An mod x raised to n equals to mod XL. So by root test, if limit is less than 1, then series is convergent. That is, if mod x is less than 1 upon L, then series will converge. Which series? Series n is equal to 1 to infinity, the power series an x raised to n converges absolutely. And if limit, that is mod XL, this is mod XL limit, and if limit is greater than 1, then that is mod x is greater than 1 upon L, then this implies that the series n is equal to 1 to infinity an x raised to n diverges. So this is what we wanted to prove. Basically, this proof depends on root test. Thank you.